Okay, so now that we looked at the second order partial derivatives, you can basically continue on and keep applying partial derivatives to get higher order partial derivatives. And basically, you just need to follow the notation and apply the partial derivatives with each variable one at a time. So for example, here, we're using the same function from example 4 so that I don't have to calculate the second order partials again. So here I'm asked to outcalculate this third order partial derivative. And so if you remember the subscript notation, you go from left to right. So the partial derivative should go xy first and then y again. So to do this third order derivative, I first need the second order derivative f sub xy. And again, this is coming from example 4. So I've already calculated it here. So let's just copy it down. It's minus sine xy minus xy cosine xy. So it's minus sine xy minus xy cosine xy. Okay, so now I can do the third order partial derivative, right? So fxy y. So now I'm differentiating with respect to y. So here, this part here, I need the chain rule. So derivative of minus sine is minus cosine. The inside part stays the same. Then the derivative of the inside, y is the variable, so I'm thinking of x as the constant coefficient. So the x comes out. And then here, this part, when I'm differentiating with respect to y, so there's a multiplication here, and then this part here contains a y. This part here also contains a y. So I need to be careful and apply the product rule here, right? So I'm differentiating with respect to y. So derivative of the first part, so you get minus x, and then times this part stays the same, so cosine xy, and then the first part stays the same, so minus xy times derivative of this part, derivative of cosine is minus sine, the inside stays the same, and then I apply the chain rule. So y is the variable, I'm thinking of x as the constant coefficient, so the x comes out. Okay, so this is what we get. And so let's clean this up again. So I can put the x here in front, so minus x cosine xy, and then minus x cosine xy, and then minus here of x times x, so that's x squared y, and also negative times negative becomes a plus, so I have sine xy here. Oh, and then finally this term is the same as this term, so I can combine them. So you get minus 2x cosine xy plus x squared y sine xy. Okay, so that's this particular third order partial derivative. And just a reminder again, as you take the partial derivatives, you may need to apply the various differentiation rules, right? So this part here required the product rule, and then each of these sine and cosine required the chain rule.